You are now looking at the demonstration mixer from above and behind. This is the typical view that most operators have in real-world mixing. In position number 1, the shaft has been angled approximately 15 degrees right of center in the tank. This is the position for best mixing results with most applications. The next position, position number 2, the shaft is lined up to point directly toward the center. This position places the impeller in the middle of the solution to be mixed. You can see this position creates a vortex. And in the third position, the shaft is approximately 15 degrees left of the center line. In each case, the shaft was approximately 10 degrees from vertical. We are now going to show you the mixing results achieved with the mixer in each of these positions. The impeller size and revolutions per minute will remain constant unless otherwise noted. In position number 1, where the shaft is 15 degrees right of the center line, you will see that we have uniformity of suspension. It is obvious that the impeller size and speed in RPM have been correctly sized to achieve this result. Notice the collision of the beads is completely random, which means good mixing. When we move the shaft to the second position, directly on the center line, a vortex and swirling motion forms. Even though the surface of the liquid appears more active, the beads have collected underneath the impeller near the center of the tank. Obviously, this is not good mixing. Now the shaft is in the third position, approximately 15 degrees left of the center line. Notice that the water surface is more turbulent than the first position. However, the suspension is not as uniform as with position number 1, and instead of random collision of the beads, they are swirling in a clockwise direction. What we have seen and learned from this demonstration is that the appearance of good mixing cannot be judged from surface action. In fact, less surface motion in these examples equals more mixing.